Another tutor here with my first video, and I would like to thank you all for checking out this channel. This channel will help guide you in your math and science courses. We'll go into topics ranging from high school level to college level. High school level trigonometry, geometry, algebra, and even international baccalaureate, the IB program, math. High school level chemistry and living environment as well, and college level sciences such as biochemistry, microbiology, organic chemistry, physics, biology, chemistry, and genetics. We would also dive into algebra and pre-calculus college level. I'm so glad that you checked out this channel, and for today's topic, we'll be going over the algebraic polynomial operations, which is a part of algebra and trigonometry as well. On to today's objective. We'll be defining a polynomial, giving examples of the polynomial, and starting off with addition and subtractions of those expressions. Then going into in more depth with examples and practice questions. Further, we'll go into multiplication and division of polynomial expressions, also diving into examples of FOIL method, distributive method, and box method, and then going forward with practice questions, and then last going into review. One thing I would like to add on is that this channel will also provide more extra help if you need it. I'll be also providing a worksheet, and the link will be in the description below, and that will help you with more practice problems if you need it. And of course, the worksheet, again, I will be providing in the link in the description below. That worksheet, you'll be working on it on your own. If you have time, you can work on it. And within a few days, I'll also be uploading another video on solving each of the worksheet problems step by step. So, a definition of a polynomial. The sum of a difference of an algebraic expressions combined together. A monomial is a specific constant and a variable. So I'll explain this in further detail in the next slide, which are given some examples of a monomial and a polynomial. So 1/5 x to the 5th is a monomial, same as negative 20 y to the 3rd and x to the 5th, which is also a monomial. And 5x to the 4th is also a monomial. These are all monomials because they don't have anything added together. So basically, a polynomial, which is shown here, is one monomial subtract or added with another monomial. One side note that's also important is that the degree of a polynomial will be the highest exponent value. So for this polynomial, the highest degree would be the exponent. So as you can see, the first monomial has a 3 as an exponent. The second monomial has two exponents, one being 3 and one being 5. So the highest in general for this whole polynomial is 5. As you can see here, I put out some more examples so we could work on it together. Feel free to pause the video and try it out yourself. What is the degree of the polynomial 3x cubed minus 20y cubed x to the 5th? So for this polynomial, we have a 3, we have a 3 again, and then a 5 as an exponent. So 5 is our highest exponent, so that will be our degree of the polynomial. For the second question, we have a similar inequation. So if you can see here, in the first monomial, remember the monomial being this one specific coefficient and variable. This one, the exponent is 5. For this specific monomial, the exponent is 2. And for this one, the exponent is 5. And for the last one, the exponent is 9. Now, this was kind of trying to trick you and just thinking that the one with the 23 would be the one with the highest degree, but that is not the case. No matter what the coefficient, the number is, doesn't matter. What matters is the highest exponent. So the highest exponent here is 9. So that will be the degree of the polynomial. It doesn't matter how large or small the coefficient is. All that matters is how large the exponent is. And in this case, 9 is the largest number here. So going forward to addition and subtraction of polynomial expressions. When adding or subtracting, polynomials align with the same variable and exponent in a column. So basically, just like how you would add or subtract, this is an example of how they would align. So as you can see here, aligning will be from the same variable. It both has to be x value, and they both have to have an exponent of 3. In this case, 4x cubed and 6x cubed are aligned together. Meanwhile, both 3x, minus 3x and minus 3x are aligned together as they both have the similar variable. And they don't have an exponent, so they would both be aligned together. Here are some questions that we'll be going over. Again, you could always pause the video and try to do it on your own, and then you could always unpause the video and go back to it afterwards. So before we start, here I added in the side, rearrange in descending order. So what that means is, I'll give an example. If from this question, if 7g cubed plus 5g minus 3 was written like this, 5g plus 7g cubed minus 3, you would have to rearrange this in descending order. So basically, you would have the 7g with the highest exponent to the lowest exponent value, if there is even a lowest exponent value. So for this case, it will be 7g cubed plus 5g, and then the last being minus 3. But for this question, we don't have to do that since it's already in that order. So for the first question, it's asking to determine the sum of 7g cubed plus 5g minus 3 and 6g fourth minus 3g cubed plus 5g. So we're going to align it together, align like variables and exponents to one another. So 7g cubed plus 5g minus 3. And then if you look at the other expression, you see that they have a 6g to the fourth power right here. And we don't have a like variable with the other expression since it starts off with 7g to the cube. So we would have to put it out, 6g fourth. And then we do have a 3 cube value, so then you would align it together with the 7g cube, so minus 3g cubed. And then we also have a variable with the g as well, so then you would align it together with the 5g, so it's plus 6g. And we don't have a coefficient without a variable. So this would be how you would set it up. So we start off as how you would normally add. So over here, there is no value to add with the negative 3, so you would bring it down. So minus 3 would be brought down. 5g plus 6g equals 11g, and that's positive because we're using both a positive 5 and a positive 6. So positive plus a positive equals a positive. So plus 11g. And then 7g cubed plus negative 3g cubed is a positive 4g cubed. And then you also bring down the 6g to the fourth. And in this case, it'll be a positive since we're adding. You're pretending that there is a 0 on both sides that don't have any variables. So in this case, since it's 0 plus 6g to the fourth, it would stay as a positive 6g to the fourth. And if you noticed here, I didn't touch any of the exponents. They all stayed the same. And that's the case for when adding and subtracting. We'll go over in more detail, but in multiplication and division, that's when you start seeing a change in exponents. But for adding and subtracting, the exponents remain the same. So this is your answer. 6g4 plus 4g cubed plus 11g minus 3. On to our next question. Determine the difference between 13t to the 5th plus 7t to the 4th minus 4t plus 3 and 6t to the 5th minus 4t to the 4th plus 3t plus 6. So before we start, this is already in the descending order, so we don't have to touch it. Let's now align both equations together. 13t to the 5th plus 7t to the 4th minus 4t plus 3. Now we align it with the second equation, which also has a t to the 5th. So 6t to the 5th, align it together with the 13t, also has a t to the 4th. So then you would put minus 4t to the 4th, aligning it with the 7t to the 4th. It also has a 3t, so then we align that with the minus 4t, so 3t. And we also have a coefficient without a variable, so we would add that into it. And it's similar to regularly subtracting numbers. Think of it that way. All the variables, remember, all the variables and exponents remain the same. They'll all be brought down. Just imagine it not being there and subtracting regularly. So just to not have it confusing, we could just write out t to the 4th and t, since they're all going to be brought down anyways. So now we could go ahead and solve. So 3 minus 6, negative number, so it'll be minus 3. And negative 4 minus 3 will give you negative 7t. We already have the t, so we don't have to do anything with that. And then a positive 7 minus a negative 4, a negative with the subtraction sign, will equal to a positive sign, so it's positive 4. So basically it's 7 plus 4. Think of it that way. And you'll get a positive 11, and then we already added the t to the 4th. And the last one, 13 minus 6, is 7t to the 5th. And this is your answer. 7t to the 5th plus 11t to the 4th minus 7t minus 3. Going on to our next slide, we're going to dive into multiplying and dividing polynomial expressions. Multiplying polynomial expressions. Multiply the coefficients and add the exponents. So here's an example of what I mean. So the coefficients here are 3 and 4. So you multiply 3 times 4, which gives you 12. And then the exponents, 3 and 5, you add them together, which gets you x to the 8th. And combining those together will give you your answer, 12x to the 8th. Similarly, in dividing polynomial expressions, divide the coefficients and subtract the exponents. So you divide both 12 and 4 together, so 12 divided by 3, which gets you 4, and you subtract the exponents, so you get x to the 4th minus x squared, and you get x squared. 4 minus 2 equals 2. And your answer will be 4x. We're going to go more in depth with both multiplying and dividing polynomials in the next few slides. Here are the multiplying methods when multiplying polynomials. We have the FOIL method, the distributive method, and box method. Now, as you can see, there's a star near the FOIL method, and which I will be going back to while we're doing this together. And you don't have to do all three of the methods, but I want to teach you all three, and whichever one you're comfortable with, you could do that. So first, here are the examples. We have here x plus 3 times x minus 7. So here we're going to start off with the FOIL method. The F stands for first term. So the first term here is the x value and the x value. And when you multiply those two together, you get x squared. On to our next. The O stands for outer term. And our outer term here is the 7, which is out on the side, and the x value right here, which is also on the outer side of the equation, of each equation. And this value will be, since the 7 is a negative 7, value will be negative 7x. The next term, I, stands for inner term. And our inner term is both the x value and the 3x. So 3 times x is 3x. And our last term, the L, stands for last term. And the last term is your coefficients multiplied together, which is the 7, the negative 7 times 3. And you get 21. So if we put that all together, we have our first term, x squared, and our inner and outer, which make up our middle term, negative 7x plus 3x minus 21. We could simplify it more by using the like terms now. We could add both like terms, negative 7x plus 3, which gives you negative 4x minus 21, and then x squared. So your answer is x squared minus 4x minus 21. So we're going to figure out if this is the right answer by doing the other methods. So the answer to this is x squared minus 4x minus 21. This is the FOIL method, and this should be the same answer for both the distributive method and box method. So for distributed method, you take your values x plus 3 and then x minus 7, and you distribute. So here, x times x, which is x squared, and then you do it again, x times negative 7, which is negative x. And then you do it again with the other coefficient, which is 3. So 3 times x is positive 3x. 3 times negative 7 is negative 21. Same thing, you add the like variables together. So negative 7x plus 3x will give you negative 4x squared minus negative 4x minus 21, which is the same answer as the FOIL method. For the box method, it's similar to multiplying larger numbers. So you put it, align it into a column, x plus 3 times x minus 7. From here to here, you multiply negative 7 times 3 over and do negative 7 times x, which is negative 7x. Then you apply a 0 here, since we're going over to the next variable. So you would multiply x times 3, which is positive 3x, and then from here to here, x times x, which is x cubed. And when you add all those up together, you get negative 21, 7x, negative 7x plus 3x is negative 4x. And then you bring down your x cubed, and we get the same answer. And if it's still confusing the box method, it's just like multiplying 21 times 12, where you would multiply the 2 times 1, and you get 2. And then 2 times 2 over here, get 4. And then you would add, and then you would put a 0 here. And then you put 1 times 1, and 1 times 2, just 2, and you get 2. Adding it all together, you would get 252. It's similar to multiplying. So any method you use, the answer, it will be x squared minus 4x minus 21. Now we could do the same thing for the next example. X minus 5 times x minus 8. Your first term being x squared, your outer term being negative 8x, your inner term being negative 5x, and your last term positive 40. So if we put that all together, we get x squared minus 8x minus 5x plus 40. And you would add the like terms together again. So negative 8x minus 5x will give you minus 13x, a negative 13x. So you put it all together, you get x squared minus 13x plus 40. On to the distributed method now. We have x minus 5 times x minus 8. So distribute the x value to both x and negative 8, and we get x squared minus 8x, and then you would also distribute the negative 5, negative 5x, and then negative 5 times negative 8, which is positive 40. So your answer will be, you would also do the same thing, the like values subtracted together, so you get x squared minus 13x plus 40. So similarly, our answer is also the same, x squared minus 3x plus 40. And then for the last, we do the same thing for the box method. We align it, just like how we did the last time. We align x minus 5 and then x minus 8 together. Put a multiplication sign. So when multiplying, again, negative 8 times negative 5, 40, and then negative 8 times x, which is negative 8x, plus there's a 0 here, x times negative 5, which is negative 5x, and then x times x, which is x squared, and it's positive. So when you put it all together, 40 plus 0, which is going to give you positive 40, and then you would get negative 8x plus negative 5x, which will give you negative 13x, and then you would bring down your x squared. So again, your answer again is the same thing. On to our next and last example. Here is where that star applied for the FOIL method I'll be talking about. The FOIL method can only be used for expressions and equations that are binomials. Binomials meaning two expressions put together. For example, x plus 5 is a binomial. And then the last two examples were also both binomials. Right here, x minus 5 and x minus 8 were both binomials. X plus 3 and x minus 7 were both binomials. But for the last one, x plus 5 is a binomial, but this polynomial is not a binomial. 7x squared minus 8x plus 2 is not a binomial, it's a trinomial. So therefore, we will not be using the FOIL method. The FOIL method cannot be used on something larger than a binomial. So we'll move forward with this distributive method. The binomial situation only applies to the FOIL method. For both distributed method and box method, it can both provide for any equations, any expressions. It doesn't matter if it's binomial, it doesn't matter if it's a trinomial, or so and so. So for distributed, you do the same thing, x plus 5 times 7x squared minus 8x plus 2. So you distribute your first expression to your second expression. So x times 7x squared gives you 7x cubed. X times negative 8x will give you negative 8x squared. X times 2 will give you a positive 2x. Now we do the same thing for 5. So 5 times 7x squared will give you a 35x squared, and when we're aligning it together, when we're adding, you would put the 35x squared aligned with the 8x squared, so 35x squared, and that's a positive. And then 5 times negative 8x will get you, again, it's going to be aligned with the 2x, will give you negative 40x, and then 5 times 2, which is a positive 10. So when you add all this up together, we'll be writing it down here. So you get, the 10 goes back, it stays the same, so you get plus 10, and then 2x plus a negative 40, which will give you a negative 38x, and then negative 8x squared plus 35x squared will give you a positive 27x squared. And then you also bring down your 7x cubed, as it will stay the same. So it'll be 7x cubed. Your answer will be 7x cubed plus 27x squared minus 38x plus 10. That'll be your answer. Onto our box method, it will be the same as how we've been doing it for the previous examples. You get 7x squared minus 8x plus 2 times, and then you would have to align it with the like terms. So in this case, x plus 5, which is the x value, would be aligned with negative 8x. So then x and then plus 5. And now you would multiply it all out. So 5 times 2 is 10. 5 times 8, negative 8, is negative 40x. And then you would do 5 times 7x squared, which will give you 35x squared. You add it to, and then you put a 0 here at the bottom, and then you continue multiplying. X times 2 is positive 2x, and it's aligned with the 40x, negative 40x, and it's a positive 2. And then x times negative 8x, which will be aligned with the 35x squared, will be a negative 8x squared. And then x times 7x squared, which will be a positive 7x cubed. So we add it all up. 10 plus 0 is 10. plus negative 40x plus 2x, which is negative 38x. 35x squared plus negative 8x squared will give you a positive 27x squared. And then you would bring down your 7x cubed, since there is no other value with adding it with it. So we got both the same answer with the distributed method and the box method. And again, we didn't do the FOIL method because in this example, we had a trinomial, and FOIL method is only used for binomial expressions. Going on to our next slide, we'll talk more in depth with division. And when dividing a polynomial by a monomial, you can split each term of the polynomial. Here is an example of what I'm saying here. So basically, we have here 15x minus 5y divided by 5. What this definition is saying is that we split this specific value, and this specific value is a monomial. A monomial and a monomial put together with the subtraction or addition to create a polynomial. So this monomial can be divided in and of itself. So 15x divided by 5, like this, like so, minus, and we'll get 5y divided by 5. And you would divide it. We have 15x divided by 5, and we don't have any other variable in the 5, so we just look into the coefficient. So we do 15 divided by 5, which is 3, and we bring down the x, so 3x. So nothing happens with the x. There's no exponent, there's no variable for the 5, so it stays the same. Minus, and then here we have as well no variable. That's a y, so we just divide the coefficients, which is 5 divided by 5, which is 1, and then you bring down the y, and it's y. Or you could write it like this, 3x minus y, and that would be your answer. And here in the sticky note, we see that here in the sticky note, I added a little reminder that when dividing polynomials, just remember when you're dividing regularly. So here is an example. So if you had a larger number, so you do 12 divided by 44, and then let's break it down into a harder problem. So you would first do 14. So nothing goes from 12 times a number to get to 14. So we would just put a 1. So 1 times 12 is 12. So we subtract the 12 from 14. So 14 minus 12 is 2. And then we bring down the 4. And our last numbers are 24. And that goes into 12. So we could do 2 times 12, which gives us our answer, our 24, and we get a 0. So basically, I'm showing you this to show that it's similar in the division aspect, that we would have to do something similar like this, but with the variables and exponents added into it. So here are some examples I provided, both multiplying and dividing. So what is the product of 3x plus 7 and 8x minus 3? So in this case, you could do the FOIL method, you could do the box method, and you could do the distributed method. I'm going to choose one of the methods, and as usual, you could always pause the video and try it yourself, and you can use any method and see if you get the same answer as I do. So right now, I'll be using the distributed method. So you get 3x plus 7 times 8x minus 3. So you distribute the 3x to both coefficients in the second equation. So you do 3x times 8x, which is 24x squared, and 3x times negative 3, which is negative 9x. And you do the same, 7 with the 7. So you do 7 times 8x, which is positive 56x, and 7 times negative 3, which is negative 21. And you would add both the like terms together. So negative 9x plus 56 will give you a positive 47x. So your whole answer will be, we will bring down the 24x squared, and you also bring down the 21 since there's no other coefficient for both that needs to be added, and there's no like terms on both sides. So your answer is 24x squared plus 47x minus 21. And this would be the same if you would have done the FOIL method or the box method. So the next question is, what is the coefficient when q squared minus 3q minus 10 divided by q plus 2? So this is what I was talking about earlier with the 12 divided by 144. So here I'm going to show you what I meant by that. Q plus 2 divided by q squared minus 3q minus 10. So now we start dissecting it. So what goes into q plus 2 to get you q squared somewhere near negative 3q? So both these variables have an extra q. And as you can see, q plus 2, there's no exponent in the q here, and the plus 2 doesn't have a variable. So what we need is an extra q. So we start off with a q. So you do q times q, which will give you your q squared. And then you'd also distribute that q to the 2, which will give you 2q, a positive 2q, so plus 2q. And now when you subtract it together, q squared minus 2q squared will be 0, so that's out of the equation. And you will get negative 3q minus 2q, which will give you negative 5q. And then you would bring down your negative 10. So this is the value that's left. So now we think about it even more. What can go into q plus 2 to get it equal to negative 5q minus 10? So we don't need an extra q anymore since we don't need an exponent for this value. But we do need a number now. A number. And that number would be a negative 5. So it has to be a negative 5 because when distributing, you would get negative 5 times q, which will give you a negative 5q. And then distributing again, negative 5 plus 2, you will get a negative 10. And this division, you would ultimately subtract the two equations together. And if this specific number was a positive, we would have gotten the wrong answer. So since we put negative 5 as one of the answers, when subtracting, negative 5 minus negative 5, you get a 0. And then same thing goes for negative 10 minus negative 10. You'll also get a 0. So then now you got your answer. When subtracting a negative number, it will turn to a positive. Negative 5 plus 5 basically would be the situation here. Negative 5q plus 5q, which is 0. And then you do the same, negative 10 plus 10. So our answer here will be q minus 5. So here's a review of all that we learned today. A polynomial is the sum or difference of two monomials placed together, and the degree of the polynomial is the largest exponent in that specific polynomial. And then we went over addition and subtraction of the polynomial, and it should be arranged in where the exponents, the variables, terms are all aligned together when adding or subtracting. Multiplying polynomials, we would have to multiply the coefficients and then add the exponents. As you've seen in all the examples for multiplying, we had to multiply those coefficients and we added those exponents together. And then there's 3 methods to multiplying, which is the box method, distribution method, and FOIL method. And remember, the FOIL method is only used for binomials, but for both box and distributive method can be used for any polynomial. And finally, dividing polynomials, where you divide the coefficients and then you subtract the exponents. Remember again that I'll be posting a worksheet in the description below if you want extra practice. And you can review it and go over it and see if you have any other questions. And you could always reach out to me if you have any questions. I'll gladly answer them for you. You could always comment on the video and ask for help if you need it. If you don't understand the worksheet, that's okay, because I'll be also providing a video, step-by-step video guide on how to do each question. Thank you so much for listening and watching this video. I hope this video actually helped you a lot in your studies, and remember that you could always accomplish the things that you want to, and dream high because you could always reach it. Thanks for watching. Stay tuned for more, and like always, if you have any questions, you could always comment down below. If you liked this video, please like, share, and subscribe. Thank you, and see you next time. Bye.